Are you audible, guys? Okay, right. So the next new concept, data integrity. Okay, na? Right. So what is data integrity, guys, and how this mechanism is going to be used as? Okay, like you see, guys, here. So basically, data integrity mechanism, what it was telling us means, and what purpose we need to use means, observe. For example, okay, right. Suppose once I have to check out here. Right. Let you see, I'm creating one sample table. Okay. So my table name is EMP 55. I was created. And now age. So this is one sample table we designed, guys. EMP 55. One new table we are creating in our database memory. Okay, na? Right. After created this table, okay, if you want to call this table, so I'm calling 55. So there is no rows. There is no rows. Okay, and now I'm inserting some new rows into this table. Let you see. So insert into EMP55, sending values. Now EID 1021, name Sai, salary is some 25,000, age was 24. So now this is nothing problem to me. This was nothing problem to me. Okay, so this is nothing problem to me. Okay, na? Right. But when we are going to guys here, this record successfully, okay, this record successfully be taken out in your EMP55 table. Successfully, the data was inserted. Okay, right. And after that, can you see the same row data or the same information again I am storing into this table. Then what it was happened, guys, here, this data already existing, already there in the table, but same information again I'm storing into table. That means I'm inserting again. Can I accept this? What do you say, guys? Can you accept this? Yes, definitely. we can accept this. What happens? See, I'm just entering this. Okay, accept. Again, I'm inserting same data, again accept. So that means whenever I want to call and see my table EMP55 and to execute it here, so the same data number of times is repeated. So this kind of repetition of data, can I say it's a duplicate data? Yes, it is a duplicate data. Yes, it is a duplicate data. Okay, right. But duplicate data is also accepting into your table. But yet the thing is, why should I want to store and why should I want to accept this kind of data? When it is a duplicate, then why we need? Okay, now. So the question is coming out. The question is coming out. So when you accepting your duplicate data into table, one thing is there is no use of this data. Second one is unnecessarily wasting our memory. Unnecessarily wasting our memory. My point understand now? So these are the problem. Okay. Next one is, suppose are you inserting nulls? Null is also accepted. And the same nulls when I inserted here one more time, again accepted. So that means nulls also accepted here. Nulls also, so these are the nulls also accepted here. But what is the use of to accepting nulls? Next one is, next one is, suppose are you inserting some data 1022, the name is Alan, salary 1 rupee, age 36,000 years of age. So here age column, I'm inserting 36 years of age I'm inserting. But tell me guys here, is there any human being was there that many years? No. Okay, no. Okay now. But now tell me, whatever the 36,000 years of data I'm inserting into age column. Now that data or that value is a valid or invalid? For your age column, that is valid or invalid? Yes, definitely that is invalid. But invalid of data also accepting. Invalid of data is also accepting. So it means that, can you see my table? In this table, in EMP55 table, whatever I created, in this table, see how many, whatever the problems are there means, you have three problems are there. One is duplicate data, second one is null data, third one is invalid data also accepted. But tell me guys, whenever your table is accepting like this table, anyone accepting in your real time? Can I accept this kind of tables in real time? No, we can't accept. So we can't accept this kind of data in this kind of tables in real time, because here unnecessary data accepted, duplicates accepted, there is no meaning of data accepted, nulls are accepted. So that means my table is not having or not maintain accurate, and accurate data is not maintained. It is not maintained accurate, and consistency and realistic data is not maintained. Is not maintained accuracy or consistency or realistic data. That is called a reliable data is not maintained. So this kind of problems are we are facing, guys, here. Whenever you want to go for, whenever you want to go for, okay, whenever you want to go for to create a table without data integrity rules, without data integrity rules, once you create a table, so this kind of problems are we are facing. Okay, now? So then how to overcome these problems? That means redundancy problem. That means a duplicate data when user try to insert it, immediately I need to stop. That means I don't want to give a permissions to the users to insert duplicate data. That means restrictions of duplicates, restrictions of nulls, and restrictions of invalid data. It means that whenever user try to inserting invalid data, that invalid data also not allowed into your table. So these kind of things have to restrict now. Then how can you restricted? How can you restricted means, yes, we restricted with the help of data integrity rules. By the help of data integrity rules, we can restrict those invalid, unnecessary, duplicate, nulls data into table. That is data integrity mechanism is why the people was going to be using in our database tables means this is. So that's why the people what they will say, data integrity is nothing but okay, is nothing but to maintain accurate and consistency and reliable, consistency and reliable reliable data in so I want to maintain what now? Okay, reliable data I want to maintain in my table. Understand that? So otherwise you can say now. So real data. So when you want to maintain accurate consistency and real data, okay, data or information in your table, data or information in tables, there we required a data integrity mechanism. There we required a data integrity mechanism. And this integrity was two ways it was classified, guys, here. First one is called as a declarative data integrity. Second one is called as a procedural data integrity we called. Okay, so these are the two mechanisms, the data integrity rules. Whenever you want to apply on a table, there are two ways are there. One is a declarative integrity rules and another one is procedural integrity rules. Okay, now, but these are what, sir? Okay, so what is the differences in between means? Here observe. Declarative integrity rules are called as a, these are predefined rules. These are predefined rules. So that means already some keys we have it here. So those keys we are using on my table columns to restrictions of duplicates, to restrictions of nulls, to restrictions of invalid data. Okay now. So the predefined, that means I'm not doing anything. I don't want to write any code here. I don't want to write any logic. I don't want to write any program. Already some predefined keys are there. So with the help of those predefined keys, I can implement this integrity mechanism. Okay now. So these predefined rules, whatever it was there, so these are how it can implement means by using one of the concept is called as a constraints. And constraint is one of the topic from SQL language. One of the topic from SQL language. Okay now. So that is what. Then what about procedural integrity means? It is called as a user defined rules. That means as per user defined business logical conditions wise, rules wise, I want to maintain my data in database tables with the accuracy, with the consistency, with the realistically. Okay, no? So for that purpose here, what happened? User is writing a logic. User is writing a programming code. Okay, now. So to maintain the realistic or accuracy or consistency data. Okay, now. But how that I can implement means here. One of the concept is there, guys. Here by using one of the concept is what now triggers, and the triggers is a part of a PLSQL language. So that means it is the second part. Okay, PLSQL language. So these are the two concepts. These two concepts we are using to implement the data integrity mechanism. Okay now. Now we are part one, still we are learning part one now, so we are discussing constraints. Okay now. So declarative first we implemented, and the triggers I want to show you in the second part, PLSQL. In the second part, PLSQL. So after SQL topic, after SQL part was completed, then we enter into PLSQL. So in that PLSQL part, we will discuss triggers concept. Okay now, right? Now let me come out. The first one is called as what now? Declarative data integrity. This we can check out now. Now, so declarative integrity mechanism. So you can understand that this mechanism this mechanism can be implemented can be implemented implemented by using which topic is here? Constraint. Okay now, right? But again, this declarative integrity again classified into three types. Again, it is classified into three types. One is we called as a entity integrity, is a one rule. Second one is referential integrity. Okay. Next one is domain integrity. So declarative integrity, again, three types of rules are followed. One is entity rule, one is a referential rule, and one is domain rule. So here, what is the mean by entity? What is the mean by referential? And what is the mean by domain integrities? Okay, so that we will see it. So let you see one by one. I will explain to you what is entity, what is referential, what is domain. First, entity rule. This entity rule, what it was telling us, this entity rule, what it was telling us means, this rule is telling us each row should uniquely, so uniquely identify in a table. Okay, now each row should uniquely identify in a table. So then it is called as the entity. For example, now this is your table. Now this is your table. In table, I prepared some columns, guys. And in this table name is, for example, T1. So now some columns are there like serial number, like name, like suppose salary, something. But on this table, I'm not using any integrity rules are not applied. Okay, now we didn't apply any kind of rules on this table. Okay, right. So whenever you didn't apply any rules on this table, what it was happen, you can insert any kind of data. Suppose I inserted here 3 rows. I inserted first row, for example. Okay, suppose I'm giving 101, some A, some salary of, okay. Next one is 102 B and some salary of. Next one is what now? 103, some C, some salary of this. Okay. So guys, here tell me total 3 rows are there, and the 3 rows serial number column. Can you see each and every row serial number value is a unique 101, 102, and 103. Okay now, right? So when your table is having like this, then this table is satisfied. Entity integrity rule is satisfied. Entity integrity rule is satisfied by this table because each row is uniquely identifying. Each row is uniquely identifying with some value, unique value. See, 101, 102, 103. So that means it is satisfied entity rule. But guys, here observe, guys observe. Suppose when I try to inserting another, okay, record 103 and D and some amount of salary 1700 if I insert. But unfortunately, this row is also accepting into your table. Unfortunately, this row is also accepting into your table. But when it was accepting here, now row number 3 and row number 4, okay, serial number values are having duplicates. These are duplicates are. So whenever you have a duplicate, and now you observe your each row is not uniquely identified. Yes or no? So because row number 3 serial number 103, row number 4 serial number 103, the both are 103 means what? Now duplicates here. So not a unique. So now what happened? Now this table is not a satisfied integrity rule. So not a satisfied integrity rule. Okay now. So this is possible. Then how to overcome, sir? Means now you can see. Now to avoid this problem, I want to use on any one of column on that column, suppose I choose this one serial number column I'm choosing. On serial number column, either I can apply primary key constraint or I can apply unique constraint keys I want to apply. So whenever we apply these two constants keys, what is the nature of this primary key and primary key and unique constant means? On which column you applied your primary key and unique key, that column is a treat as a key column. Okay, that will be treated as a key column. So on which column you applied your primary key or unique key, that column treated as a key column in your table. And that key column is not allowing duplicates. That means whenever I am inserting 103, this is not allowed. So it is always allowed unique values only allowed. It always allowed unique values only allowed. So that means it doesn't allow the duplicate numbers into serial number column. That every value is a unique number is accepted. So in that cases, now each row is a unique number na? Yes or no? Each row is a uniquely identified na? Yes or no? Each row is a uniquely identified na? Yes. So this mechanism is called as a entity. This mechanism is called as a entity. Now all of you understand that, guys? Come on. All of you clear this? Entity means understand, all of you? Okay, now? Right. That means this entity mechanism implementation purpose, which constant keys I'm using here? Primary key and unique. So that means what you say? It can be implemented by using what now? Primary key and unique constants I'm using. So that means primary key and unique constants are used for what? Entity relations. That means entity here. Entity is nothing but, very important thing is, now entity is nothing but table, guys. It is okay, entity is nothing but what now? Table. Don't confuse what is entity. Entity matlab table. Okay now? So, and this integrity mechanism, if I want to implement on my table, then I should require, or I wanted, a primary key and unique constant. In these two constants, any one constant you can use to maintain each row is uniquely identifying in a table. Okay now? So to implementation of that mechanism, each row should be uniquely identified in a table. So that mechanism implementation purpose, we are using primary and unique. Right? Now, next one is referential integrity. What is a referential integrity means? Referential integrity is nothing but to create a relationship, in between tables, and this implementation purpose we required, we need what we need here? We need a foreign key constraint we required. Which one is required? Foreign key constraint is required. So foreign key constraint especially we are using to making a relationship purpose. To making relationship purpose. So referential integrity is nothing but creating relationships in between tables. And for that purpose, we require a foreign key. Okay, now? Right. That how to do this all, I will show you practically. So don't hurry, worry. First, I'm explaining one by one definition. Later, I will show you one by one practically. Okay, now? Right. Next one is what now? Domain. Domain integrity is the next one. What is domain integrity means? Domain is nothing but, guys, domain is nothing but column. Domain is nothing but column. So whenever we are inserting some values or values into a particular column, that column value or that value, I need to check whether it is valid or invalid. So that means domain integrity mechanism, what it was telling us, to check values, whether these are valid or invalid. So that was checking. Suppose your value is invalid, then immediately the data will be removed, not allowed. So when data is valid, then only accepting into column. Okay, to check values before inserting into a column. Okay, before inserting into a column. Okay, this is domain. Domain is nothing but column. Every column in a table is called as a one domain. Okay, and into that columns, when user inserting data or values, those values are verified or checking, okay, by your system with the help of some integrity rules. If that is true, that means valid, accepting. If it is invalid, not accepting. Then how it can be implemented means we require or we need here two constants I'm using here check and comma. One more I'm using what now? Not now. These are going to be two constants we are using to check your values. Okay, either right or wrong, valid or invalid, true or false. Okay, by the help of domain integrity. Okay, now so finally here whatever I'm using the constants, like I'm using unique constant, like we are using not null constraint, now we are using check constraint, now we are using primary key constraint, now we are using foreign key constraint. So foreign key constant. So whatever we are using, these are the total 5 constants here. These are called as a what now? Constants we called. These are called as a constants. But these all constants, the main purpose, aim, ambition, target, what it is means, the main purpose of constants, these are all total how many? 5 constants. These all 5 constants, the main target, main aim, main purpose is what now? Okay, so these are all constants are used to enforce or else restrict or restricted, to enforce or restricted what here? Invalid data. Restricted invalid data into a table. Okay now, so these all constants are, what is the main purpose of these constants means I need to enforcing, otherwise restricting what I want to restricted, invalid data, unnecessary data, unwanted data. So whenever user trying to insert either fortunate or unfortunate, whenever user trying to inserting some data, that data I want to restrict. That is the main cause of constraints. Okay, then how we can restricted your data means by using of different constant keys. Okay, like a unique is a one way of mechanism, not null is one key, check constant is one purpose, primary key is one purpose, foreign key is one purpose. So like this what happened, every constant we are using to restricting of data in different manner, in different ways your data is restricted. So that is the main cause of your constant. Now these constants are simply, we can say what are the constant types means, suppose here, so constant types or types of constants or constant types. So these are the types of constant. Okay na, unique, not null, okay, check, primary and foreign key. Okay now, and this foreign key, even though we can call it as what now, references key also we call, we call as references called. Okay now, but here all databases, whatever it was there, all databases are supporting how to define constants on your table columns. Means all databases are supporting, okay, all databases are supporting the following two types of, the following two types of methods to define constraint, on columns. Okay now, so first one is called as a column level constraints, is a one level, and second one is called as a table level constraint, is another level. Okay now, one is column level, one is table. That means constants can be applied, in two levels we can apply. One is a column level we can apply, and one is a table level we can apply. Okay now? But what is the differences in between column level and table level? Okay, let you see. So column level is called as, in this method, constants are, okay, are defining or defined, okay, constants are defined at each column wise, So column level means what now? Every individual columns wise, each individual columns wise, when you applying your constraint, or else when you applying your constant on each individual columns wise, then it is called as a, column level we call it. Okay now the syntax observed. So what is the syntax here? Create table name of column name 1 and suitable data type size. After that you have to send your constraint type. Okay now, this is one column, comma, column name 2 data type size, and here I want to apply again constant type. So that means what happened guys here, if you see carefully, every individual columns wise we applied your constant. Okay now, every individual columns wise we applied constants. That is called a column level. So are you clear column level? Come on guys, are you clear the syntax? Okay, so right. So what happened here, every column, okay, so your required column name, suitable data type and size, and after constant type you can apply. So like this every individual column wise we applied. Okay now, right. Second one is what now, table level. So table level means what now, in this method we are applying constraints or define or define, okay, are defined after all columns definitions are completed, then end of the table definition, end of the table definition we can apply. Okay now, so this is table level. In table level what it was happening guys here, first I'm going to creating my table with how many number of columns you want to create. First create, don't apply any constraint. After all columns definitions are defining or completed, then end of the table definition apply. Okay, now see the syntax. When you see the syntax you can understand. The syntax is what now, create table name of, now we are sending column name 1, data type, if data type is required size, first column is over. Like this you can define all columns, column name 2, suitable data type size. Okay, next we have to define like this, column name 3, suitable data type and size. Okay, now after defining all columns like this, end of the table you need to write a constant type, pass end of the table constant type of, again you are sending column name 1, okay, column name 2, comma, and so on, and this is close. So column level syntax and table level syntax carefully identify, then what is the difference you understand. So now the two syntax differences are there. Come on, guys. Are you identified? What is the difference? Okay, now? Right. So the differences understand now? Right. So this is what it is. So table as well as column. Okay. And now one example we will see. The first example we will discuss on unique constraint. So what is unique constraint means? Here also. The nature of unique constraint is, okay, unique constraints are restricted duplicate values but accepting nulls into a column. Okay, now carefully observe. So unique constant nature is what now? Restricted duplicate values but accepting null values into column. Let you see, I will show you first example on column level. I'm showing you. First example on column level. Let you come out. So this is my database, guys. Here so many tables are there like this. Okay. Okay, right. So now I'm creating option. Create table EMP11, suppose. Serial number, otherwise test 81. Okay. Serial number integer, and here I'm applying unique, comma. Name I'm using here varchar 2 of some size, and here applied unique. So now in this syntax or in this example, can you see for every column after definition, I was applied my unique constant. So serial number is defined, unique constant. Name column is defined, unique constant. This is called a column level. Are you understand now? Are you understand now? Come on, guys. Come on, guys. Are you understand now? Column level, how to define? Understand all of you? Yes. Okay, now? Right. So like this, you can apply your unique constant on individual columns. Like any number of columns. Any number of columns means your table is accepting maximum 1000 columns. Maximum 1000 columns in a table. So 1000 constants we can apply. Okay, now? So this is column level. After applying, your table is created. Now I need to insert your data. Let me see what it was happened. Test number 81, sending values of serial number 101, name is Sai. This is my first record, so there is nothing problem. It was accepting into your table. Let you come back and see your table test number 1. So, sorry, test number 81 now. So combine and see test number 81, then it is allowed. But guys, here tell me, when I'm going to inserting here, the second record, I'm inserting 101 comma Adams, I'm inserting. But already serial number column is already existing 101, and are you inserting again 101? But already 101 is existing in your table column. But again, are you sending same number? Can you accept duplicate values? Accepting duplicate data? No, not at all. Okay, now this is the nature. Now, what you said? Restricted duplicates. Restricted means not allowed. Duplicate values. Okay, let you see if I inserted here error. What is my error? Unique constraint is violated, and here your system is showing one identity number that is called a constant key identity number is generated. So what is constant key identity, that I will discuss with you after some topics are over. I will discuss with you. Okay, na? So later we will see. Okay, what is that? I will show you. Now we can see what it was saying. Unique constraint is violated. Now can you come out and see what table 101 one more time is allowed here? No, not allowed. So now, okay, fine. Now I'm inserting, next one is, suppose I'm inserting here values of 102 I'm inserting, and now I'm going to inserting Sai. But guys, here Sai is already existing in your name column, and name column is also which type of constant I was applied? Unique constant. So that means the name column is also not allowing duplicate data. But here duplicate data Sai I'm inserting. Can you say this record is allowed or not allowed? Yes. Yes. This is also not. Yes or no? Yes, this is also not allowed. Now this time what happened? Again, unique constant is violated. Now system is generating some number. This number is what now? 79. Previous number is what now? 78. So C double 06078 and your C double 06079. So these are identities. The what it is identities we will see later. Okay, now. So here also not allowed. So let you come out your table. Let you come out your table. Not allowed. So that means what you understand, guys, here? Your serial number column is not allowed duplicates. Your name column is also not allowed duplicates. Why? Because on these two columns, I was applied unique constants. That's why unique constants are not allowing duplicates. Okay, now. So, but here, suppose, okay, duplicates are not allowed. We check it out. If I insert nulls, for example, if I insert null comma null, can I insert? Can I insert, guys, null comma null? Yes, it is allowed. See, one row is created successfully. Again, can I insert? Again, one more time, can I insert null comma null? Yes. So that is the reason we said here. What we said, unique constant restricted duplicate values, but accepting null values into column. Now we can see the two, like this, any number of times you can insert nulls. After that, suppose I'm sending like this here. Suppose I'm sending 102 and the name is Adams. Can I insert now? This record, can I insert now? Okay, right. Now let you see it's happily accepted, and let you come out your table test 81 and see 101 Sai, 102 Adam. This is called unique values, unique data, but duplicates are not there, but nulls are allowed. Duplicates are not there, but nulls are allowed. Okay, now. So this is one example of a column level unique constraints, how to apply at a column level. So column level example is understand now. Ah. Now what is the second one is? What is the second one is? Table level. Now how to apply at a table level? How to apply at a table level? Okay. So that we will see in tomorrow's session, guys. So tomorrow we will go for to continue the table level and next level of constants. Okay, now. So all of all of you received a joints topic. All of you received a joints notes. Joints notes. All of you received a. No, yeah. My people are just now they forward before this class started. They forward. Once check out. Once check out. All of you. Yeah, yeah. They said they forward just now before class started. This they forward you. Once go to check out. Yes, received. Okay. Yeah, just now oh, that I'm telling. Before this class started, they received. They sent to you. Okay. Okay, guys. Fine, guys. And this is what, and we'll continue tomorrow, guys. Here. Thank you. Thank you so much.